So for number 2, multiplying polynomials, again, I'm going to draw my little distributing arrows over the top. That's how I remind myself that I'm actually distributing. 2 times a positive 4 is 8. And then what happens to the y and the x squared? What does that become? X squared y. Try to keep your variables in ABC order. It'll help your brain. I promise, especially when you start factoring. So try to keep your variables in ABC order. So I'm going to write that, yes, as x squared y. Ding dong, dang it. Okay. And then 2y times 5xy. Well, 2 times 5 is 10. And then the y times the xy becomes xy squared. I'm so sorry, ma'am. What can I do for you? Yep, got it. Thanks, got it. Diane Sawyer, checking out your tech. I'll get you tomorrow, don't worry about it. Okay, so what did we say this was? 8x squared y plus 10xy squared minus 2 times negative 3 is negative 6y cubed. Are we good with that? Okay. All right, so now I have a binomial times a binomial. So for this, we can either use the double distribute, right? Or we can use FOIL. I just try to first, outside, inside, last. That's kind of how I draw my arrows. So the first term times the first term. Then I'm going to do the 2 outside terms, then the 2 inside terms, and then the 2 last terms. That's what FOIL means. I just draw my arrows. Take the first term and multiply it by both terms in the second parenthesis. Over the top is how I draw my arrows. And then take the second term and multiply it by both terms in the second parenthesis. And I draw my arrows across the bottom. So 4x times 8x, well, 4 times 8 is 32. And x times x is x squared. 4 times negative 6, well, that's negative 24. And x times y is just that, xy. 4 times a positive 8, well, that's a positive 32, xy. And then I have a positive 4 times a negative 6, that's a negative 24. Y times y is y squared. Are we finished with that one? No, what do I need to do with it? What do you think, McKinley? Yeah, I have a negative 24 and a positive 32. What's 32 minus 24? 8. So it really becomes 32x squared plus 8xy minus 24y squared. Okay. Number 4, same thing. You have a binomial times a binomial. So 3x times 6x, well, 3 times 6 is 18. X times x is x squared. 3x times 6y, well, 3 times 6 is 18. And x times y is just that, xy. And then across the bottom, 2y times 6x, well, that's a positive 12 xy. And 2y times 6y is a positive 12 y squared. I can combine these two terms in the middle for 18x squared plus 30xy plus 12y squared. Are you guys good with that? Am I going too fast? Yes? Lainey, do you not have your packet at all? Did you lose your whole packet? Okay, okay. All right, so for number 5, tell me what's going on there. What am I multiplying? A what times a what? Times a, yeah, I'm taking a binomial and multiplying it by a trinomial. So FOIL doesn't really work. So we're actually just going to distribute. So I'm going to take x and I have to multiply it by each term in the second parenthesis. So let's do that first. X times 6x squared is 6x cubed. Good job. X times negative xy is negative x squared y. Good job. And x times negative 2y squared is negative 2xy squared. Perfect. Now I'm going to grab a different color, and I'm going to do the second term of the first parenthesis, which is a positive 6y, and I have to multiply that by each term in the second parenthesis. So 6y times a negative 2y squared gives me, well, positive 6 times negative 2 is negative 12. And what happens to my y's? They become y cubed, right? Sorry. I went all the way to the bottom. I'm stopping that. Reverse. Don't listen to that. Sorry. Try that again. Sorry, video. Okay, so 6y times 6x squared becomes a positive 36x squared y. 6y times negative xy becomes a negative 6xy squared. And 6y times a negative 2y becomes a negative 12y cubed. Okay, so what are some things that I can group together? Well, how many terms do I have that are x squared y? I have this x squared y, and I have this x squared y. I don't have any x cubed, so I'm going to leave the 6x cubed the way it is. And what is negative x squared y plus 36x squared y? A positive 35x squared y. Now let's group these terms. I have a negative 2xy and a negative 6xy squared, sorry. So what do these two terms become? Just add the constants. Negative 2 and negative 6 become negative 8. And we're combining like terms. I have xy squared. That doesn't change. And then this last term, there are no other y cubes, minus 12y cubed. So that's your final answer. Okay, I'm going to pause the video. I want you guys to do number 6. You try number 6. I'm going to freeze my screen. Who's ready to share their answer? Rosie, did you get it? That's exactly what I got. So positive 8m cubed minus 10m squared n plus 29m n squared plus 8n cubed. So I think for the next couple of examples, we're going to use the box method because maybe a visual representation will help you guys, but maybe not box yet. Did everybody get this one? Okay. So I want half the room to do number 7. So Staley and Sydney and Alexis and everybody close to the door is going to do number 7. And then Kaylee, Courtney, Rosie, and everybody close on this side to the wall is going to do number 8. Ready, go. Evan, you're doing number 8. Number 8, you're on this side. Raise your hand when you have number 7 figured out. Okay, number 7. Lanaya, what'd you get? Perfect. 49m cubed minus 42m squared n plus 14mn squared. Number 8, who wants to share their answer for number 8? We're still working number 8? God bless you. What'd you get, Courtney? Okay. That's exactly what I got. 6x cubed y to the 5th minus 24x squared y to the 6th minus 6xy to the 7th. Good job. Good job. That one made you nervous because of how high the exponents were? Yeah, you did that right perfectly. Okay. We're going to do one of these two. Which one do you want to do? Let's do the first one. Okay. So I have st to the 6 u cubed. I'm going to multiply that by each term in the second parenthesis. So there's no constant here, so I'm just going to draw number 1 in front of it. So 1 times -2 is -2. S times s is s squared. T to the 6 times t to the 6 is t to the 12th. U to the 3rd times u to the 5th. Sorry, u to the 2nd is u to the 5th. Okay, remember that when the base is the same, we just add the exponents. Now I'm going to take my 1 times a +3. So 1 times +3 is +3. S times s to the 4th is s to the 5th. T to the 6th times t is t to the 7th. U cubed, there's no u, so that u cubed comes along for the ride. Last one is I'm just multiplying that first term by -4. So I'm just going to put a -4 in front of it and keep the s t to the 6th, u to the 3rd. Now I have to do the next term. So I have -5 s to the 4th tu, and I'm going to multiply that by -2 s t to the 6th u squared. So -5 times -2 is a +10. I'm just putting it down below. S to the 4th times s is s to the 5th. T times t to the 6th is t to the 7th. U times u squared is u cubed. Now I'm going to take this -5 and multiply it by 3. That gives me -15. S to the 4th times s to the 4th is s to the 8th. T times t is t squared. And there's no u in that, so that u just comes along for the ride. And then when I take that -5s to the 4th tu and multiply it by the very last term, -5 times -4 is a +20. And then just repeat the s to the 4th t And now we're going to take the last term, which is the positive 2u, and multiply it by everything inside. So positive 2 times a negative 2 is a negative 4s t to the 6th u cubed. And then I have a 2 times 3, which is a positive 6 s to the 4th t u. And then I'm just going to take 2u times negative 4, which gives me negative 8u. So let's see what we can group together. This is why I wasn't doing the other side, because I know I need that space to like write my grouping. So are there any s squared t to the 12th u to the 5th powers anywhere else? No. So that can't be grouped with anything. So my final answer is going to start with negative 2s squared t to the 12th u to the 5th. Are there any other s to the 5th t to the 7th u cubed? Yes, right here. Do you guys see that? Yay or nay? Okay, so a positive 3 and a positive 10 become positive 13 s to the 5th t to the 7th u cubed. So we've taken care of this and this and this. Are there any s t to the 6th u cubes? Yes, this is also an s t to the 6th u cubed. So I have a negative 4 s to the t to the 6th u cubed and negative 4 times t to the 6th u cubed. So negative 4 become negative 8 s t to the 6th u cubed. And I'm going to scribble this one out and this one out. Do we have any s to the 8th power t squareds? No. So that negative 15 is going to be next. Minus 15 s to the 8th t squared times u. And then I have a 20 s to the 4th tu and a 6 s to the 4th tu. 20 plus 6 becomes a positive 26 s to the 4th times tu. And then the last one is minus 8u. And I know that was a lot. 6 terms. Okay. We're going to do I'm going to just do one of each example for the box method, because some of you guys like the box method. I saw a couple of you actually draw this out on your homework. So when you use the box method, the first term, whether it's a term by itself or a term in a parenthesis, that's what goes on the outside vertical. So 5t to the 5th. This is the outside and it's vertical up and down. 5t to the 5th. The inside the parenthesis goes horizontally across the top. And this is how we set up for factoring. So this is helpful to use the box method. So do you guys remember we did an example like this in when we first started multiplying? What do I do here? Because this is just kind of like a times table. Any ideas? What do you have, Lorelai? Sorry, Lanaya. Yeah, so 5 times negative 7 is negative 35. And t to the 5th times t to the 4th becomes t to the 9th. Good job. So then for the next one, I have 5 times negative 11, which is negative 55. T to the 5th times t to the 3rd becomes t to the 8th. All right, I'm going to keep going down to this one. So again, my first term is always, I always write this on the vertical. So negative 5s and negative 7. And then my second term goes along the horizontal, 4s and 8. Okay. So I have negative 5 times positive 4 gives me negative 20. And s times s is s squared. Staying with the top row, I have negative 5 times a positive 8 gives me negative 40. and the s comes along for the ride. Now I'm going to do negative 7 times 4s. Negative 7 times 4 is negative 28. Bring down your s. And then negative 7 times 8 is negative 56. And when you use this method, typically, not always, but typically you will be able to combine the two terms that are diagonal. So my final answer is negative 20s squared. Negative 28 and negative 40 become negative 68s minus 56. So that's what it looks like when you set up a binomial times a binomial using a box. Can I go to the next one below it? So here I think we have a trinomial times a binomial. So the binomial is the first term. So that's why I only have, my vertical is only 2 boxes high. So 2x squared y and 3xy. And to that, I'm multiplying across the top x squared, a positive 3x, and a 4. So let's see, 2, there's no term up front here, so I'm going to put a 1 in front of it. 2 times 1 is 2. X squared times x squared is x to the 4th. Y. 2 times 3 is 6. X squared times x is x cubed. Y. And then 2 times 4, 8. Bring your x squared y along. Now I have 3 times x, 3xy times the x squared. So 3 times 1 is 3. X times x squared is x cubed. Bring down your y, and hopefully you see that these two terms are going to be combined because they're on the diagonal. Again, I said it doesn't always work, but typically it does. 3 times 3 is 9. 9, and then x times x is x squared y, and hopefully you see that these two terms are on the diagonal, and those are going to be able to be grouped together or combined. And then 3 times 4 is 12xy. So the first term in this first box, there is no other x to the 4th y, so that's just going to be 2x to the 4th y. But the next term, what am I adding to that? What is 3x cubed y plus 6x cubed y? Yeah, 9x cubed y. And then the next term is going to be what? 17x squared y. And then the last term cannot be grouped with anything either, plus 12xy. Do you guys like that method? Not really. Okay. We'll do a 3 by 3 just so you can see what it looks like and see how they match up for groupings. No. There might be an instant where you can't combine these because you don't have the same x squareds, like you're not following the same pattern, but it's never going to be, well, I shouldn't say never. Rarely is it going to be that you can group this with this, right? That's hardly never going to happen. Okay, I'm going to go to this last, this should be your last one, right? A 3 by 3. So we're going to take a trinomial times a trinomial. So on the vertical, I have x squared on the outside the first box, then a positive 3x, and then a positive 4. And then going across the horizontal, I have x cubed, a positive 6x squared, and a positive 2x. All right, so I'm going to multiply. X squared times x cubed becomes x to the 5th. X squared times 6x to the second power is 6x to the 4th. X squared times 2x is 2x cubed. Are we good with that? Okay. 3x times x cubed is 3x to the 4th. 3x times 6x squared is 18x cubed. And 3x times 2x is 6x squared. 4 times x cubed is just that, 4x cubed. 4 times 6x squared is 4 times 6 is 24x squared. And 4 times 2x is 8x. So let's look at what we can group together. You see we have 2 terms to the power of x to the 4th. Then we have 3 x cubes that can be grouped together. And then we have 2 x squareds. I think I like this method because it kind of helps you line up what you're grouping together versus like doing that crazy search. So I know that x to the 5th is the leading, like highest degree polynomial, right? Or highest degree monomial. So that has to go first. So x to the 5th. And to that, what am I adding? Yeah, 9x to the 4th. Good job. And then to that, I'm adding what? 24x cubed. And then to that, I'm adding what? 30x squared. And then to that, I'm adding 8x. Okay. All right, so I froze that for a second. I'm going to stop our video, possibly.